So the next thing that we're going to try to do is how to create probability distributions. So here we have a problem. So suppose you have, or you flip a coin 2 times, and we want to let X be the number of heads that result. Find the probability distribution of this experiment, right? So the way that we're going to go ahead and do this, right, if we remember, probability distributions can only be between a table, a graph, or a formula, right? But in this case, we're just going to deal with tables because it seems much more easier, right? So we are going to say, okay, well, X is going to be the number of heads that result, right? And then I'm going to write the probability of X, right? So remember, X is just the number of heads, right? Now, what are the possibilities that I can get heads? Well, let's go ahead and look at the sample space. So I can get heads twice. So I get a head and a head, a tail and a head and a tail, or a tail and a tail, right? So these are basically the only possibilities that I can get heads, right? So I can get no heads, I can get 1 head, or I can get 2 heads. Can I get 3 heads? No. Well, I only tossed it twice, right? So there's no way, right? So now what we got to do is like find the probability of all of these occurring. So what is the probability of getting 0 heads? Well, there's only one outcome that has 0 heads, right? And that's just 1 out of 4, right? So this is just equal to 1/4. So we can just write it as a fraction or a decimal, whatever we'd like. What is the probability of getting only 1 head? Well, we can only get 1 head when we get tails heads or heads tails. That is 2 out of 4, or in other words, 1/2, right? So that happens 1/2 chance. What's the probability that I get 2 heads? Well, that occurs 1 out of 4. Okay. And remember that in order for us to make sure that this is a probability distribution, we have to make sure that all of our probability adds up to 1, right? So clearly 1/4 plus 1/2 plus another 4th equals 1. 25 cents, 50 cents, 25 cents gets me $1, right? Okay, so that's just basically it. So whenever you see the word probability distribution, right, basically what I'm telling you to do is construct a table of this experiment and try to sort out all the outcomes and all the probabilities. Okay, so this brings us to the next question. So this question is a little bit more involved. So suppose you roll a fair 6-sided die and the following can occur. So if I roll a 2 or a 4, I win $10. If I roll a 1, I lose $15. If I roll anything else and you don't lose anything or gain anything. Okay, so these are 3 different possibilities that can happen. So I have a fair 6-sided die, right? So I have a 6-sided die, right? So something that looks like this. Sorry, my evil laugh. Sorry, my cat was doing something weird. If you hear a bell, then you know that it's her. Get off the table. Okay, so we have a fair 6-sided die. So we're gonna go ahead and roll it. So if we get a 2 and a 4, a 2 or a 4, right? I win $10. Okay. If I roll a 1, right? So if I get a 1, I lose $15. So I ended up losing, right? If I roll anything else, well, what are the only thing that's a possibility, right? Well, I can get a 3. I can also get, what else? A 4, no, a 5, and I can get a 6. So if I get any of these, right, I get nothing, right? I don't win anything and I don't lose anything, okay? So what do we want to find? We want to find the probability distribution of the amount of money you win, okay? So what is the amount of money that you win? So I'm going to say X is money I win. Okay, that's the first step that you want to do. Just set up your probability, or your random variable, I'm sorry. So I'm going to have X here, the chances that I win, right, or the money that I win, and then the probability of that occurring. Okay, so what can I win? I can win $10 easily. I can win $0, right? So I can win nothing or lose nothing. And I can also win what? Well, not $15, right? Because I'm losing. Well, how do we signify I'm losing? Well, negative. That means I have negative return here, right? I don't have anything, right? So now what are the probabilities of each of these occurring? So the probability of me getting $10, well, I can get that by rolling a 2 or rolling a 4. So that's going to be 2 out of the possible 6. Sorry, that was my phone. What is the probability of getting a 0 or losing or gaining anything, right? Well, that's just 3 outcomes, right? So that's just 3 out of the possible 6. And what is the probability that I lose or win negative $15? Well, in this case, I can do that by rolling a 1. 1 is 1 out of 6. Okay. Now remember, it's all out of 6 because we only have 6 sides of a fair die, right? As you can tell, right, I add all of these up and I also get 6 out of 6, which should equal 1. So this is the answer for part A. Okay. Now, what about part B? Part B says, how much money do you expect to win? Okay, well, how am I going to find how much am I expecting to win? Well, the way that you can probably do it is, well, let's see, I can win $10 2 out of 6 times. I can win $0 3 out of 6 times. Or I can win negative $15 1 out of 6 times, right? So, I mean, I could easily just add these numbers together, right? Because I'm basically taking the average of the 10 plus 0 plus negative 15, add them all together, divide by 3, and then try to get something. But that's not really what I'm doing, right? Because I'm not always going to get $0 and I'm not always going to get negative $15, right? So we have to incorporate the probability somehow. So what I say, right, what I propose is taking, well, I can win $10 2 out of 6 times, or, right, I can win $0 3 out of 6 times, or I can win negative $15 1 out of 6 times. Notice that the or was just an addition, right? So I'm going to go to my calculator. I know that this is going to be a big fat 0, right? Because that's just going to go away. And I'm going to take 10, multiply it by 2 over 6. And I'm going to add it to negative 15 times the probability of that occurring, which is 1 out of 6. And what I'm going to get is about 83 cents. That is how much I expect to win in this particular game. Okay? So I found my experiment. I was able to list out all the outcomes and the chances of those occurring, and I was able to find the expected value. So that's actually what we call part B, expected value. And here are actually the formulas, right? So expected value, which we also call the mean, right? All we just do is take all of our outcomes, x's, right, which is here's all of our outcomes, right? What we found here. Take all of them and then multiply it by the probability of them occurring and add them all together. That's what we call expected value. So this is actually the mean, right? Mu, or the expected value of x occurring, right? Something else that we can find the standard deviation, okay? Well, we'll do that in the next video.